Good morning. Welcome to the Yongsan Baptist Church English Sunday School. This is now the 19th of December. Wow, really close to the end of the year, really close to Christmas. And we are continuing our series in evidences from geology, biblical creationism. You might have made it through last week's video. You might not have made it through last week's video, so we'll do a little bit of a review. But currently, after we've looked at the wonders of geology relative to what we can learn from them, how about select? There we go. Now we're looking at evidence from geology about radiometric dating. And we looked last week at the basics of radiometric dating and how what it means about atoms and the nature of chemical analyses and all of that. But we talked a little bit about how assumptions are involved in radiometric dating, and how even though radiometric dating is often used to prove rocks are millions of years old, once you understand the basic science, and you can see how wrong assumptions can lead to incorrect dates. Most people think that radiometric dating has proven, that the Earth is billions of years old, yet that view is based on a misunderstanding of how radiometric dating works. In part one last week, we saw how scientists observe unstable atoms changing into stable atoms in the present through radioactive decay. We talked about that process. In part two today, we'll see how scientists run into problems when they make assumptions about what happened in the unobserved past. And that, if you didn't know, is a rampant problem in science in general. And assumptions can be okay as long as you go about to test those assumptions. We read something yesterday, just as a side note here, that said, trust the science is literally the most unscientific statement you can make. Because in order to do science, you must not trust science. In order to do science, you must come about it, as we talked about several weeks ago, now months ago, I guess, we talked about the definition of science and how it has to be from a point of falsification. You have to question science, you have to try science, and you have to prove, in the biblical use of the word prove me now, saith the Lord, right? He means test me, put me to a proving process, not prove as in it's proven and it's done with. Okay, so question science, but in that process, be careful of your assumptions and be ready, especially when it comes to the unobserved past, to allow your worldview and your assumptions to be tested. Okay, so last week we also discussed this hourglass analogy of dating rocks. Boom. When we look at sand in an hourglass, we can estimate how much time has passed based on the amount of sand that has fallen to the bottom. Radioactive rocks offer a similar clock in this analogy. Radioactive atoms, such as uranium, that you see off to your left there, atoms of uranium, over time, to become stable, must decay into stable atoms like lead, in this case. God bless you. And this would be a parent isotope and a daughter isotope, as we discussed last week. The sand grains, right, can be measured of the parent isotope, and such as uranium-238 or potassium-40 or several others that we looked at last week. Scientists can also measure the amount of what's in the bottom hole, the daughter isotope, right, and that it would be like lead-206 or argon-40 respectively. Based on these observations and the known rate of radioactive decay that they can measure, they estimate the time that it has taken for this daughter isotope to accumulate in the rock, right? Now, unlike in the hourglass situation, where the accuracy can be tested because it's a closed system, by turning it the other way, right? Comparing it to trustworthy clocks and everything like that. Reliability of a radioactive clock has to be assumed, and it is subject to at least three unprovable assumptions. So no geologist was ever present when that radioactive clock formed to see the contents, and no geologist was present to measure how fast that radioactive clock has been running through the supposed millions of years. So assumption number one, as we'll get to here, sorry, I'm going to go back and forth with the computer. Assumption number one is conditions at time zero. Since no geologists were present when rocks formed, they cannot test whether the original rocks also contained daughter isotopes. They have to assume that it was 100% pure uranium or potassium, so forth, right? For example, in the volcanic lavas that erupted, flowed, and cooled to form the rocks in the unobserved past, evolutionary geologists simply assume no daughter isotopes of argon-40 were in the lava rocks originally, and that the time clock started from that cooling point, and that it was only through time that argon was added. For the other radioactive clocks, it's assumed that by analyzing multiple samples of a rock body or a unit, today, it's possible to determine how much of the daughter isotopes like lead, strontium, or neodymium were present when the rock formed. This process is called Isochron Technique, and it is a technique, and it does yield numbers, but it's still based upon the second and third faulty assumptions. So it's prone to the same issues that we're seeing here. So the lava flows that have occurred in the present, though, have been tested soon after they erupted, and they invariably contain much more argon-40 than is expected. For example, we talked about Mount St. Helens. Okay, that was what I was just talking about. But we talked about Mount St. Helens, right? And when a sample of the lava flows from Mount St. Helens that happened observably in 1986 were tested in 1996, only 10 years later, it contained so much argon-40 that it had a calculated age of 350,000 years, even though we know it was only 10 years old. Similarly, lava flows on this mountain in New Zealand, which were known to be less than 50 years old, yielded ages of up to 3.5 million years. So it's logical to conclude that if recent lava flows of known ages yield incorrect old potassium-argon ages due to the extra argon-40 that they inherited from the erupting rock, then the ancient lava flows of unknown ages could likewise have inherited extra argon-40 and yield incorrect old ages. There are similar problems with the other radioactive clocks, not just potassium-argon dating. We've talked quite a bit about the Grand Canyon, and this on the very north rim of the Grand Canyon is a lava flow of known age that's happened fairly recently. These lava cascades are visible if you go to tour the Grand Canyon. And obviously these eruptions took place recently after the canyon's layers were deposited because the lava is on top of the layers that we can see. So the basalts, and remember we talked about basalts as being magma that cools where? Under the surface or on the surface?
On the surface?
Yes, that's right. So we had the two forms of rocks, and we had the ones that cool under, and then the ones and that's the like granite and other rocks cooling below the surface, and then the basalts at the surface, like Giant's Causeway and the one that we talked about on Jeju. Okay, so the basalts here yield ages of like 1 million years based on the amounts of potassium argon, but when they are dated with rubidium and strontium isotopes, they yield an age of 1.143 billion years. So the same age there's no way that can happen. But that same age from the rubidium strontium is given for the basalt layers deep below the walls on the eastern side of the Grand Canyon. So not the ones that are up here at the top, but ones that are really deep below are yielding that same date. So again, that's super confusing. But how could both lavas, one at the top and one at the bottom of the canyon, be the same age based off of their parent and daughter isotopes? One solution is that the recent and the early lava flows inherited the same rubidium-strontium chemistry, not age, from the same source deep in the Earth's upper mantle. So if there was a standard chemical ratio of those isotopes, both parent and daughter, beneath the surface in the mantle, and so that one eruption and then another eruption 1,000 years later could yield the same relative amount because the chemistry in the mantle stayed the same over that course of time. Again, it's just a theory. But this source already contained both rubidium and strontium. It wasn't that it was pure rubidium and had to decay to strontium. To make matters even worse, for the claimed reliability of these radiometric dating methods, the same basalts that flowed from the top of the canyon yield a Sumerian neodymium age of about 916 million years and a uranium lead age of 2.6 billion years. That's a pretty large deviation. I don't care what kind of science you're in, that those are not trustworthy numbers if different methods yield such drastically different ages. Okay, assumption number 2. We'll jump into that, see how far we can get. No contamination. The assumption here is that even though physicists, on that screen? I think I'm on that screen, yeah. Physicists have carefully measured the radioactive decay rates of parent isotopes in laboratories over the last 100 years or so. I'm sorry, I'm on the wrong one. I skipped ahead one. The problem with contamination, as with inheritance, is that it's already well documented in textbooks on radioactive dating of rocks. It's just ignored mostly in the public. And like we said before, most people just don't understand radiometric dating and don't get into it enough. Unlike the hourglass, where the two bowls were sealed, that we saw that, these radiometric clocks in rocks are not actually sealed system. They are open to the environment around them. And because of that, they can have gain and loss of these parent and daughter isotopes with water flowing through the rocks, ground water, rainfall, other molten rocks in volcanoes, subsequent volcanic lava flows. Similarly, as molten lava rises through a conduit, right, like we were talking about tubes in the earth where there's a conduit of rock where the lava is able to get up to and then escape out of a volcano, that conduit rock, the wall rocks of that conduit can also give contaminants, right, to the lava that before it comes out. So it's not just from the mantle, but also from the rocks that that magma is going through as it erupts. So there's contamination in multiple sources. And just such contamination is what it figured here. What? Okay, back. This is actually, I'm already there. This is the lava flows at that mountain in New Zealand. So because of such contamination, these less than 50-year lava flows that in a mountain Nuku'alofa, something like that, in New Zealand, yield a rubidium strontium age of 133 million years, a samarium neodymium age of 197 million years, and a uranium lead age of 3.908 billion years. Which one do we trust?
Yeah.
How about none of them? How about none of them? So assumption number 3, really quickly, is the constant rate of decay. The constant, oh, come on, back. There we go. Constant rate of decay. Physicists, like I said, had carefully measured the radioactive decay rates of parent isotopes in laboratories over the last 100 years or so, and have found them to essentially be constant within their measurement error margins. So furthermore, they've not been able to significantly change these decay rates, right? We have in a lab changed the speed of light and different other things, and magnetic pull, and we've adjusted and affected other rates, but we have not been able to find a way to significantly affect the decay rate of radioactive elements. So using heat, pressure, electrical, or magnetic fields. So the geologists then, because the physicists haven't been able to change it, assume that radioactive decay rates have been constant for billions of years. Again, that's a faulty assumption. However, because it's an enormous extrapolation of 7 orders of magnitude back through immense spans, right, 106 billion years, immense spans of time that are unobserved time, and there's no concrete proof that such an extrapolation is credible. So geologists insist that the radioactive decay rates have always been constant because that's what makes their clocks work. And if without that constant, then the clocks don't work. New evidence, however, has recently been discovered that can only be explained by the radioactive decay rates not having been constant in the past. The radioactive decay of uranium that is listed here as 704 million year half-life. The radioactive decay of uranium in tiny crystals that they found in New Mexico within the granite yielded a uranium-lead age of 1.5 billion years, but the same uranium decay also produced abundant helium out of the crystals, right? When we talked about the 3 decays, we talked about alpha particles, beta, electron particles, and then gamma rays, right? Photon rays, electrons, and then particles. So the alpha particle degradation, helium is the element that's being given off as it decays from uranium to lead in that alpha decay, radioactive decay. So that those helium particles can be measured as well, and in those crystals, only about 6,000 years worth of helium had escaped the crystals. So that number sounds familiar. However, the means what that means is that the uranium that has decayed had to have decayed in that same 6,000 year window of the helium decay, because if there's no evidence of helium decay or release before that, then that means that there was no alpha particle decay. So that means it was 250,000 times faster of a decay rate at some point in that 6,000 years of uranium to lead than we can observe today. But the book that I was just showing here has a whole lot more about that I'm not going to get into. It's called Thousands, Not Billions by Dr. Don DeYoung, and it goes into that and several other different topics. Great, one of several resources that lots of these Answers to Genesis and Creation Today and other ministries offer, the Institute for Creation Research offer all of these different books with lots of people spending lots of time going down deep on all of these issues to speak about the fact that these measured rates are not what they seem to be. So again, three assumptions that we can look at that are obviously faulty, and radioactive dating is not only unprovable, but it's plagued with problems. So as this list is illustrated, rocks may have inherited parent and daughter isotopes from their sources. They may have been contaminated when they moved through other rocks to their current locations, or inflowing water may have mixed isotopes into the rocks. Additionally, radioactive decay rates have not been constant, and we can see evidence of that. So if these rocks are based on faulty assumptions and they yield clocks, not rocks. If the clocks are based on faulty assumptions, yield unreliable results, then scientists, if they are truly scientists, should not trust or promote the claimed radioactive ages of these countless millions of years, especially since they contradict the true history of the universe as recorded in God's Word. So next week, we will look at how the Bible's history helps us to better make sense of the patterns that we see in radioactive dates. Because even though the numbers we don't agree with, the patterns can still be trusted as reproducible science. And we'll look at that next week. So let's pray, and then we'll get on to the service.